In this video, we're going to take Numpy Arrays in Python, and we're going to look at some neat things that we can do with them. One neat thing about these arrays in Python is that if we want to do something to every single member of the array, like add 1 or divide by 2, we don't have to iterate or loop over the array and say, this element add 1, that element add 1, that element add 1. Instead, we can just use a mathematical operator and whatever number we want to add to each element, and it automatically says, okay, I will increase each element by 1, or whatever it happens to be. So let's look at a few things we can do here. First, I'm going to go ahead and import our two libraries. This will be fairly common. And then after that, I'm going to tell it to not word wrap if I have an excessive amount of data. We're not going to actually need word wrapping in this demo, but it's one of those kind of boilerplate things, always a good idea to do. Now, let's make effectively a two-dimensional NP array. You see a couple things I did here. First of all, I'm using a similar data type, in other words, a floating point data type across all of my data entries because Python's going to figure out what the data type is, and I want to make that fairly straightforward. Secondly, we have several square brackets going on here. We have the outer square bracket, and then inside of that, we have two sets of inner square brackets. Note what that does is that effectively creates a two-dimensional array, where this is a row, and this is a row, and then 1.5 and 0 are in a column, minus 0.1 and minus 2.0 are in a column, and 3 and 6.5 are in a column. We can describe this multi-dimensional structure by using a shape, and as a matter of fact, we can just say data.shape, and that will return to us 2 rows and 3 columns, or 2, 3. Now let's try that math I did earlier. Let's say I said data plus 1. Notice it takes all of our entries and adds 1. So 1 plus 1.5 is 2.5. 1 plus minus 0.1 is 0.9, so on and so forth. I used the plus operator here, but of course I could also say data minus 5. And we'll see here that we get minus 3.5 as our first entry. And you notice minus 5.1 is our second. Now I might say, wait a minute though. 2.5 minus 5 is minus 2.5, not minus 3.5. And, 0.9 minus 5 is going to be minus 4.1 or something like that. Well, note that this is just displaying. I said data plus 1 here, and that's just displaying the output. It's not actually modifying that original data collection. So down here where we say data minus 5, it's using the same data we have up here because this didn't modify it. I could modify it if I wanted to. I could say data equals data minus 5. Or actually, I'll tell you what, we'll just go ahead and run them all. Data equals data plus 1, so we should get similar output on that. And sure enough, you see, okay, 1.5 plus 1 is 2.5. We'll just confirm once again when I enter data here, and you see that, yeah, the data have actually changed. Now I could say data equals data minus 5, and then print out data. And now it's going to take these values and subtract 5. So 2.5 minus 5 is minus 2.5, 0.9 minus 5 is minus 4.1, and so on and so forth. So see, by adding that assignment, I'm effectively saving the values. Now, I am going to go ahead and reverse it back to what it would have been had I not done all this math, which is easy enough. Minus 5 plus 1 is minus 4, so adding 4 to it should take us back to what we originally had. And sure enough, we see there 1.5 minus 0.1, and so on and so forth. Now, let's do some comparisons. What if I want only the data items that are greater than 1? Then I can say data greater than 1 and take a look at what we get in return. We get boolean values, true, false, false, true. It's effectively looking at this collection, and if it's greater than 1, it puts in a true. If it's less than 1, it puts in a false. Greater than 1, a true, so on and so forth. And this gives us a boolean mask. This will come in, this will be useful in a little bit because we can do things like say, is there a value here? If not, or actually turn that around and say, is there not a value here? And then we get a series of trues where there's an invalid value. we could use that to say, okay, give me only the rows with invalid values, or reverse it, say give me only the rows with valid values. And when we're looking at cleaning up data for use in data mining, that kind of use of a Boolean mask is quite handy. Now, of course, we can also say data less than 0, and we'll get back not identical, but a fairly similar result, so it shows us only the negative values. Now, the neat thing is we can also default those negative values to a default value. So let's say data and then square brackets, which means I want to select elements from this data collection. Inside of the square brackets, I'm going to say data less than 0. So my condition is select only the ones that are less than 0. Now, the cool thing is I can use an assignment operator here and say if it's less than 0, then default it to 0. So in other words, we're putting a minimum on our collection that nothing should be less than 0. And if it is, we'll just make it 0. So we take a look at this, and we see we have one item that was already 0, but the two that were negative, sure enough, those have now become 0. We can have Python generate some numbers for us, and we can have them increase. By default, they increase by a unit of one integer each time, although we can tweak that and say increase it by tenths or hundredths or something, or even tens or something like that. But that's an interesting way to kind of make up some data. And I'm going to do this in two parts. I'm first going to make the data, and then I'm going to reshape the data to match our collection so that we can do some math on it. The method we want to call here is called arange, but be careful, it's not a range. A range has two R's. Range with only one R. I've typed two R's many, many times. Say I want to give it 6 elements, and we see, sure enough, 1, 2, 3, 4, 5, 6. Now I'm giving it a reshape, which says, okay, it's currently effectively one dimension. It's a line or a list of numbers, and I want to turn that into a two-dimensional structure. So I simply issue the reshape command that changes it from one row with effectively 6 columns to 2 rows with 3 columns, and you see that matches our data up above. So the neat thing now is we can add these two data sets together. And there we go. 0 plus 1.5 is 1.5, 1 plus 0 is 1, 2 plus 3 is 5, 3 plus 0 is 3, 4 plus 0 is 4, and then 5 plus 6.5 is 11. So you see we're able to generate some numbers that fall in a sequence, and we're able to add two collections together provided that they are the same shape. Now that we have the big numbers collection, we can do a few computations on this, like looking at the mean. For the mean, we can look at the columns or the rows. Let's start by looking at the columns. So notice axis equals 0 means get the mean of each column. So 1.5 plus 3 is 4.5 divided by 2 is 2.25. 1 plus 4 is 5 divided by 2 is 2.5, and so on and so forth. Not a big surprise, but if we want to look at the mean across rows, we simply change that axis to 1. And now 1.5 plus 1, 2.5, plus 5, 7.5 divided by 3 is 2.5. And you see that's giving us the mean across rows. Now, let's add a little bit of noise to our data, but a bit of predictable noise. And I'm going to do this by getting a random distribution, or a random set of numbers across a standard distribution. Note that it's kind enough to take a size parameter, which should be in parentheses, and that's going to not only give us a random set of numbers, but give us to it in a particular shape. And in this case, it's going to match the shape of our larger data we've been working with, so that we can effectively sum or difference these together as we wish. And there you see numbers that follow a normal distribution. Now we could say big numbers equals data plus normal distribution. Let's see. Let's say big numbers equals big numbers plus normal distribution. And you see now we have a little bit of noise in there. We could also change that to a multiplication, which might be interesting since we have some negatives in there. Division, or any of the other common mathematical operations, even square root and exponent, are supported. But it's handy that the shape of these data matches, because Well, it looks like we're adding two collections together. We're actually adding each of the elements at each of the same locations together, or subtracting or multiplying or dividing, or whatever we're doing. But either way, you've seen several ways now that we can generate some data, either generated by hand or increasing data or random normal, and there's several other ways that we can do this. It's all quite straightforward with Python. So I hope you found this video helpful, and I look forward to reading your feedback. Thank you.